Okay, if you are in 7 Excel, we are working from the Advanced 2 textbook. If you are in Math 8, we are working from the Course 3 textbook. We are doing lesson 5.4, extension, and it can be found on pages 230 and 231. So for the past few weeks, we've been working with systems of equations. And the book has given us 2 equations that look like this, because we know a system is more than one. So the book has given us 2 equations that look like this. Sometimes they're in slope-intercept form, sometimes they're in standard form. But we know that when we have a system of equations like this, we've got 3 ways to solve that system. We can graph, we can use substitution, or we can use elimination. And right now, I want to focus on what substitution looks like. Let's focus on what substitution looks like. So when we've got a system of equations like this, and we're using substitution to solve, we take this expression right here and substitute it for y. So we end up with negative 3x plus 1 equals 2x plus 2. Then we combine like terms and we solve for x, and then we take that x and we substitute it back into one of our original equations to figure out y. Well, today, we're going to be doing the same thing, except the book gives us an original equation that looks like this. X minus 2 equals negative 1/2 x plus 1. So take a look at this and look at this equation here. They're very similar. So for us to be able to solve this, we need to turn each expression into an equation. So I'm going to take this expression, y equals x minus 2, and turn it into this equation. Then I'm going to take this expression and turn it into an equation. Y equals negative 1/2 x plus 1. We now have a system of equations that we know how to solve. We know that we can solve this system of equations with a graph, by substitution, or by elimination. So that's what we're going to be doing today. The book is going to be giving us an equation that looks like this, and it's our job to break both expressions down into an equation so that we have a system of equations that we can solve with a graph, by substitution, or by elimination. So let's do another one. The book is giving us 6/10 x plus 12 equals 1 2/10 x plus 9. So we need to turn each of these expressions into an equation. So I'm going to take this expression and turn it into the equation y equals 0 6/10 x plus 12. Then I'm going to take this expression and turn it into the equation y equals 1 2/10 x plus 9. I now have a system of equations that I can solve by graphing, substitution, or elimination. I want to do one more with you. The book has given us this, 2x plus 3 equals 4. Okay, but Miss Colburn, where's all the other stuff on this side? I don't know. Let's see what we can do. Let's take this expression and turn it into an equation, y equals 2x plus 3. Then let's take this expression and turn it into an equation, y equals 4. Oh yeah. Remember when y equals 4? It is y equals mx plus b. It's just that our slope is 0, which makes x 0. So therefore, all we have is the b. So in this case, it is a flat line and there's no slope. It's flat, so the slope is 0. So here we have a system of equations that we can solve by graphing, substitution, or elimination. So let's go ahead and do one of them. Let's go ahead and do one. So the book has given us, do I want to do 2x plus 3? Nah, let's do this one. The book has given us 1 and 5/10 x plus 2 equals 11 minus 3x. So the first thing I need to do is take this expression and turn it into an equation. Y equals 1 and 5/10 x plus 2. And let's take this expression and turn it into an equation. Y equals 11 minus 3x. Oh, my variable is after my constant. What do I do there? Well, according to the commutative property, it doesn't matter what order these are in. So I can reverse that order, and this is now in slope-intercept form. So I now have a system of equations that I can solve by graphing, substitution, or elimination. So let's take this system and let's solve it by graphing first. Okay. So here, my y-intercept is positive 2. My slope is positive. It's going to go up. And I'm going to go up 1.5 and over 1. Up 1.5, over 1. Up 1.5, over 1. Up 1.5, over 1. So this line represents this equation. Now, let's take a look at our second equation. My y-intercept is 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. My slope is negative. It's going to go down. And I'm going to go down 3 over 1. Down 3 over 1. Down 3 over 1. Down 3 over 1. And where my two lines intersect is the solution. So it looks like my solution is always xy, and it looks like my solution is 1, 2, 3, 4, 5. So it looks like my solution is 2, 5. Now, in this original equation, we may only have to find x. The problem may only ask us to find x. And if that's the case, x is equal to 2. So here we've solved this system of equations using a graph. Now, Let's solve this system of equations using substitution. So let's use substitution. So we have y equals 1 5/10 x plus 2, and y equals negative 3x plus 11. I am going to take this expression and substitute it for y. So I now have 1 5/10 x plus 2 equals negative 3x plus 11. Now take a look at this. We're using substitution to solve, and look at what our original equation was. This is what the book originally gave us. 1 5/10 x plus 2 equals 11 minus 3x. Look what I have. 1 5/10 x plus 2 equals 11 minus 3x. So let's go ahead and solve for x. I want to get this x over here. So I'm going to add 3x. What I do to one side, I must do to the other. So I have 4 5/10 x plus 2 equals 11. I want to isolate this variable, so I want to get rid of this positive 2. So I'm going to subtract 2. What I do to one side, I must do to the other. 4 5/10 x equals 9. I still want to isolate this variable, so I'm going to divide by 4 5/10. What I do to one side, I must do to the other. X equals 2. Very nice. So now I'm going to come back up here to my original equations, and I'm going to pick the easiest one to work with. And frankly, I think this one's going to be the easiest because there's no decimal. So y equals negative 3x plus 11. I'm going to take x equals 2 and substitute it right here. Y equals negative 3 times 2 plus 11. Y equals negative 6 plus 11. Y equals 5. So my solution is always xy. My x is 2 and my y is 5. So my solution is 2, 5 again. And like I said, at the beginning, they may not ask for an ordered pair. They may just ask for what does x equal. And if that's the case, we already figured it out back here. We didn't even have to do this because we already figured it out back here. But if we worked the whole thing out and we came up with an ordered pair for a solution, we would still know that x is equal to 2. And let's solve this the third way using elimination. So let's solve this the third way using elimination. So we've got y equals 1 5/10 x plus 2, and y equals negative 3x plus 11. So I want to alter one of my equations so that when I subtract, I eliminate a variable. So in this case, since I have a positive 1.5x and a negative 3x, I'm going to multiply this whole equation by positive 2. Positive 2. So 2 times y is 2y. 2 times 1.5x is 3x. And 2 times 2 is 4. So now we can bring this whole thing over. Y equals negative 3x plus 11. And when I add these together, these guys cancel each other. They are eliminated. So 2y plus y is 3y equals, these guys have been eliminated, 15. I want to isolate my variable, so I'm going to divide by 3. What I do to one side, I must do to the other. So y equals 5. So now I'm going to come back up here to my original equations, and I'm going to substitute 5 in. And once again, I think this is going to be the easiest equation to work with because there aren't any decimals. So we're going to take this and substitute it for y. 5 equals negative 3x plus 11. Okay, I want to isolate my variable, so I'm going to get rid of that positive 11. What I do to one side, I must do to the other. So I've got negative 6 equals negative 3x. I still want to isolate this variable, so I'm going to divide by negative 3. What I do to one side, I must do to the other. Negative 6 divided by negative 3 is positive 2 equals x. So once again, here's my x. And here's my y. My solution is always in xy. My x is 2 and my y is 5. So we have, this is what the book gave us. We separated each expression and made each expression an equation. Then we had a system of equations that we could solve by using graphing, substitution, or elimination. So that's what we're doing today.